Hello guys, let us look at the concept of dimensional analysis. In some of our previous videos, we've been able to derive the dimensions of physical quantities, the dimensions of the derived quantities. So in this video, we're going to look at how to use this dimension to analyze simple formulas in physics. One of the applications of dimensional analysis is to check the correctness of formulas. So in this video, we're going to check one formula using dimensional analysis. So we have the question here. It says, check if the equation v squared equals to u squared plus 2as is dimensionally correct. To solve this problem or to check if this equation is dimensionally correct, we're going to check the dimension of the left-hand side of the equation, which is v squared. And we are going to check the dimension of each of the term on the right hand side of the equation, and if they are the same across the entire equation, if they are homogeneous, it means the equation is dimensionally correct. So let's start with v squared. The dimensions of v squared is equal to, remember that v is velocity, and the dimension of velocity from what we've derived previously is lt raised to power minus 1. Then v squared will be lt raised to power minus 1 all squared. And if we square that, we have L squared, and minus 1 times 2 gives us minus 2. So we have L squared t raised to power minus 2 as the dimension of v squared. Now we're done with the left hand side. Let's go to the right hand side. The first one here is u squared. U squared is equal to, u is also velocity, but this is initial velocity. And velocity has the same dimension irrespective. So we're going to have the same thing we have here will be repeated here. And this is the dimension of u squared. And the last term here is 2as. One thing we have to note is that 2 is a constant and there is no dimension for a constant. So we're going to omit the constant and look for the dimension of as, where a is acceleration and s is distance. This is a simple equation of motion in physics. So in our previous video, we looked at the dimension of acceleration a, and that is lt raised to power minus 2. The dimension of distance is l, so we're going to multiply both of them. And if l multiply l, that gives us l squared, and we are left with t raised to power minus 2. So the dimension of the as is equals to l squared t raised to power minus 2. So looking at this carefully, we'll find out that the dimension on the left hand side and the dimension of each of the term on the right hand side are the same. So we can conclude that since the dimension of the left hand side is equal to the dimension of each of the terms in the right hand side, then the equation v squared equals to u squared plus 2as is dimensionally correct. Now try this. Check if the equation a equals to vt is dimensionally correct. Please put your answer in the comment section. Thank you for watching.